So let's talk in general about vertex form of a quadratic for a second, so we can tell where we find info. So what is the point of the vertex? Well, this is in vertex form. It tells us it right off the bat. The vertex is just the point HK. So this value inside, opposite of what we think, is our x value. This value on the outside is our y value for the point of that vertex. Remembering that the vertex is this top point if it opens down, and it is this bottom point if it opens up. So we have our vertex, I'll call it V, are these 2 points. Okay? Well, what is the equation of the axis of symmetry? If I know the vertex, then I know the axis of symmetry right off the bat with h. So x equals h is our axis of symmetry. Does it open up or down? Well, a, the number in front, tells us that. If a is positive or greater than 0, it opens up. It takes on a shape like this. So think about it this way. Positive, boop. If a is less than 0, if that number in front is negative, it opens down. So it takes on a shape like this. So the way I remember it, to draw that sad face, hopefully one of those will keep in your mind as you're working through these. Dilation, how do we tell if it's been stretched or compressed? This is by A. A tells us that. It tells us how far to stretch or compress it. So, walking through 2 examples, we have f of x equals 2, x minus 2 squared plus 5. Vertex, I'm going to call it V, is 2, the opposite of -2, 5, the same. The axis of symmetry, AOS, I'll call it for now, is x equals 2. It is that x value from the vertex every time. It opens up because A is positive, and it's dilated by 2. Because A is 2, that is the dilation. That's how far it's stretched. So for example, vertex, -1, -3. Axis of symmetry is x equals -1. It's that x value. It puts a line through the point. This one opens, because this is negative, it opens down. And the dilation is it's dilated by 1/2. So in other words, it will end up being compressed because 1/2 is less than 1, so it squishes everything together by 1/2 in terms of y values.